Just download the link or signal I sent you in WhatsApp. And open your Google Collapse too. I will wait for like 5 minutes or something. I think that's enough. Okay, there's a Q&A. I'll see. Send it here, please. Okay. But you have to download it. How am I supposed to send it in this? Let's see. No, I don't think I can send it here. Yeah, you can see the code right now and make a signal yourself, actually. That would be better. I'm assuming you can see this right now. I will import libraries currently. You just type what I am typing. I will teach you what each and every line does, but just all that command starting with import is just dumping libraries in your code currently. And if you've got any errors, just send the errors in Q&A. We'll see and try to solve them right now, if possible. This is where all the files are dumped currently. You just type till right here. I guess that should do it. Now we are going to define a low pass filter. This def function allows you to make a function in Python. Function is something you can dedicate a task to and use that repeatedly. And this low pass will take in data. This is a variable I'm giving it takes, and type this exactly. Make sure there is no spelling mistakes or that will just turn up to be a syntax error. np.nd array is just a way of NumPy storing data or a signal in some way. Cutoff, it is a float. Float is a variable as number. In Python, float meant something number as with decimal points like 4.67, 4.88. All of the numbers are called float. Integers are just integers in float like 5, 6, 7 or something. And cutoff can be anything. That's why I'm giving it as float. And we'll give sample rate as also a float. Sample rate is how many times you take the readings of signal in 1 second. You can't have continuous signals in Python. Every signal is a discrete signal in Python. Discrete in the sense you will take readings in certain intervals and try to interpret what the complete signal looks like. I guess I have to give space. And we'll give polls as int equals 5 and add this. Polls is the order of the filter. I'm giving fifth order because the more the order, the better the filter is. Add this colon here and press enter. Type exactly as I'm doing. I will explain later what this line does. It's already showing me what to type actually. You can just tab, but I will write it anyway. Dot signal dot butter is a function in this script.io dot signal script.io dot wave files, which take in all these values and give us what we need exactly. Polls, cutoff. Now this press single quotes and type low pass. This is actually optional, but I would like to do this because I'm also going to code high pass filters and band filters in this. So it's better to segregate them. And sampling rate here, you can just press tab and do all this, but I'm just going to type anyway. And yes, this. Now what butter function does is it takes all these values and effectively makes a low pass filter and effectively makes an out low pass filter and name that out low pass filter as SOS. We defined a variable and made it an low pass filter basically with this line in itself. Now SOS is a low pass filter. Now let's type filtered data as an variable and I will use just type what I'm doing and you'll get to know why I'm doing all this. Now I made a separate variable as filtered data and this signal takes the data and passes it through SOS. What is SOS? A low pass filter which is made by butter function. And this function takes the data and passes it through SOS and gives a single variable. And we stored that single variable as filtered data. That's all this function does currently. And we will type return filtered data. This just self-explanatory. This returns whatever is stored in filtered data. Returns in the sense sends out. That should do it. And now we will give sample rates. Mind here, there should not be any space in between this. This space indicates that this all part is in this function low pass. If I don't give this space, then the Python recognizes this as a separate line currently. Sample, okay, sample rate, comma data equals scriptkey.io dot wave file dot read singly wave file dot read. Let's type signal dot wave. Oh, we also have to add the file here, but we will do it at last. Times equals np dot. You might have be familiar with this function arrange from the first session of signal processing. We will type length of data. I pressed tab by mistakenly. Yeah, you can type till here length data by sample rate. Now filter equals. Now we will apply the low pass function here. Let's take cutoff frequency as, let's say, 25 actually. Sample rate. Yeah, and that should do it. And we have to plot, but before that, press this files here once and let it connect to Python. So we will wait. And once this is done, press this upload thing. Open the whatever file I have sent you in WhatsApp, which will probably be in your downloads. Press that and open it. It will give a warning, but press OK. You will see signal.wave. This line just reads whatever is there in the signal.wave and takes the sample rate from the signal and gives it to sample rate and whatever data is present in that will give it to data. You can directly give equals to, but it will not have separated the sample rate and data. So this function helps us separating sample rate and data. So it helps us basically reading this file. And we have just applied the slow pass filter here. Data is whatever we gave in signal. Cutoff frequency is 25, sample rate, and pose is predetermined, so we need not give it again. Now let's plot this. For plotting, I have to again write quick comma. Try to do what I'm exactly doing. Actually, the Google Colab is giving me everything, but I'll just type it anyway. In case it didn't come to you as a suggestion, I'm typing it. Subplots. Let's say 1, comma 2. Subplots basically means we are having multiple pictures or multiple graphs, and 1, 2 is the dimensions of those. 1, 2 basically means 1 row and 2 columns. So we will have 1 row in this and 2 columns. Like we'll have 2 graphs, one here and one here probably. And I will like to give it fixed size also. It gives us power to control the size of each graph. I'll keep it 10, comma 3 because it looks nice actually. Yeah, I think that's enough. You don't have to deal with all this. Now I'll give axis 1, comma, sorry, dot, plot, times, comma, data. This is actual signals plotting. And I will also give axis 2 dot plot dot times, comma, filtered. Plot dot show. And we could also give it plot dot type layout. This will just make sure that they are joined together tightly. Yeah, I think that's should do with it. There might be some errors. Okay. So first I will explain you whatever the signal I have sent you. The signal is just P sines combined. One sines frequency is 5 hertz, and seconds is 50, and thirds is 100. I joined them three, and this became the signal. As I kept cutoff frequency as 25, two other sine waves got attenuated or just removed, and we just got a signal whose frequency is 5 hertz. Now, if I change this frequency as, let's say, 75, we will have two sine waves combined. The two sine waves gives us like this. And if I just keep it as some bigger number, 120, nothing gets filtered, so we will get the same signal as our output. This is just same as both. I think you got it till here. You can see whole code in the single page. I'll just see Q&A for the column. Send the file in channel. May I know which channel are you talking about? YouTube channel. Whoever got the Python part, just raise hands. I will go to next code. If you have any problem, please press it in Q&A. We'll see. Many people are not getting the file signal, I guess. Okay, one guy got. Okay, I think you forgot to add the uh, wave file in files. Did you add this thing? You press files here and you upload the signal I have sent you. Yes, I added. Okay. A module name file here. Check this line properly. I think you made some error in this dots, or you forgot to import this scriptfile.io.wave file. I got the error. You have pressed comma in front of wave file. Scriptfile.io dot wave file, not comma i file. Wave file. Yeah, you missed this dot here. I think that should solve it, everything. Okay, I think everyone is done with this Python part. I will just go to the next code. Where did you send the signal? Okay, in the discussion group. In Summertronics discussion group, I have sent it. And now it's going to be added in channel as well. The length of input vector must be greater than pattern, which is 18. What? I added it in WhatsApp channel. I think it didn't get to you. I will just send the direct code in the Q&A group. That should solve your problems for whatever error there might be. I'm taking time a lot of in this because everyone is mostly interested in Python, in my opinion. And also the feedback is the coding part was done very fast. So I'm taking as long as I can. Just copy paste this. I think that should solve problems in syntax errors. Original recording.wave. I think you change the file. I suppose you change the name of the file. If you change the name of the file, you have to rename in the Google Colab as well. You have to right click and rename whatever you are going to type here. Okay, I will go to the high pass filter currently. We are again going to define a function as high pass filter. Def high pass, same as previous. Data cutoff, sampling rate. This should get suggested to you directly without me doing anything because you have already written same function above. In case of band pass filter, it's different. We'll do everything in this. Again, an SOS script dot the suggestion it gave everything. This is basically it. Giving it an high pass, butter made SOS and a high pass, and we pass the same thing again. And let's do all this again. But okay. I'm going to remove this low pass and make it high pass. I'm not going to type all this again. This should help you all as well. And high pass, we will give it as frequency some, what shall we give? 40? No, wait, not 40. We'll give it 75. It is showing some errors for me as well currently. Let's see. Yeah, I thought I made a spelling mistake, I guess. Okay, I think this all of this should be below this. Yeah, now it's working. The problem was it reads from top to bottom. So when I said high pass here, it didn't know what high pass actually was. In in C language, you will not get this problem, but here you are getting it. I pressed the 75, so we got the 100 frequency one. If you add something like, let's say 3, you'll get the same as everything in the signal is more frequent than 3. Like 5 hertz, 50 hertz, and 100 hertz is what I gave. We got the same signal. I think that's okay by everyone. We're almost reaching the end of this session currently. Please do be stay at last for attendance, by the way. Send it in. I don't see any Q&A. You are free to type any Q&A. I'm here as long as you have doubts. You will also get just codes and everything at last. And also the task I'm going to give it to you is based on Python also. I think we can stop with this Python. You can you can post doubts in discussion group. I'm always there to help you with errors. We are running correctly late, so I will stop this Python for now. Let's go back to slides. Actually, the slides are also almost at the end. Now I'm going to tell you what's the phase shift meant in this signal processing. When given in Python, you don't actually get phase shift because it's done ideally. The perfect filter exists only in Python. You can have perfect filter in Python. But in reality, if you give it if it give it to actual electronics parts like RC or active filters, you'll get phase difference between output and input. Like phase difference is this picture is self-explanatory actually. This imagine the red line is as output and blue line as an input. If you stop the signals at any point, you can see the peaks are not aligned at the same point. There is some difference in between them. This length is called phase difference, the difference between those both. You might have heard the phase a lot of time, but this is what it actually meant. Hope my slides are not lagging now. I'll go slow over this. Each reactive element introduce a 90-degree phase shift. 90-degree phase shift means the length is in degrees or in radians. Like pi by 2 is the distance between those peaks, or it can be 90 degrees. It depends on how you measure your x-axis. If you give it as 40 degrees, 45 degrees, then it will be 90 degrees or just vice versa. Reactive elements are, you can learn a lot about them, but in RC circuits, reactive elements means capacitors. Capacitors or inductors are known as reactive elements. I will also show you the graphs of second order filters and third order filters, but let's go through this first. You can read all these points. They are mostly self-explanatory. I'll also explain it again. I think that's time. I will show you. The next slide will make this point and this point way clearer. I'll wait for the animation. I think that's done. You have seen this graph for low pass filter. Now this is the phase shift. Initially the phase shift is 0, but it's increasing till 45. 45 is where the cutoff starts. Like cutoff point is the point where phase shift is 45 degrees. And the rate of increase of phase shift increases till cutoff and then it decreases like this. This is the phase shift graph. What the third point suggests is for this phase shift graph, it is not 10 kilohertz, 100 kilohertz, 1 megahertz. This is logarithm of this. Like this point is log 100k for this. Log 100k for this, log 10k for this. log megahertz. It is observed that for logarithm frequencies, this shows 45 degrees at cutoff and all. You can get all these values by calculating or just seeing the formulas and try to match the frequencies at what the phase shift will be. And we'll go to second order filters now. Okay, is there a question? Someone raised their hands. The slide is not changing. Can you tell which slide are you stuck right now? Our second order filter or has again do this once? Okay, the slide is not changing actually. What happened is I think it's changed now to second order filters. Okay, it's changed. Okay. Second order filter is funny actually. This is just two first order filters joined together and that itself became a second order filter. You can make nth order filter by connecting infinite terms, but reminder, you will get attenuation at cutoff frequency. That is, the output will become 1 by root 2 times. So if you add 2 of this, the output will become half 1 by 2 and 1 by 2 of that. 1 by root 2 and 1 by root 2 of that. So by adding this, one downfall is you will get way more attenuation at cutoff. But also you want way more attenuation, then that's your advantage. This is the passive second order filter. This is active second order filter. Active second order filter is nothing but a first order passive, but you will have some amplifier or transmitter attached to it. This amplifier helps in increasing the altitude. By now, I think you should have known. And this is the actual graphs. The first order, it will, okay, I think this changed. Like, it mean, just see once if it changed or not. I think it changed. The first, more the order, the sleepier, slanter the slope will become. And this is the ideal graph. It will be a sharp one. It's impossible to get this perfectly. You will have some sleepiness. And I will go to the last simulation of this session and we'll end this by that. Now changed. Okay. I opened a new tab. I hope this is sharing its screen. Again, type online simulator circuit one last time. And we go to this multism. Actually, you need to sign in for this. It is free account. Just type login and enter your email address. That should just create an application for you. This is free of cost. This basic part is free of cost. You can add up to 5 components. That should be fine for our simulation currently. You just do your login. I'll wait for some 3 minutes or so. Multism this, by the way, if I click too fast. I remind you if you have any doubts in Python codes or you're getting any errors in Python code, or you have any doubt in simulations I've showed before this Python, like Polstad one, you can always message me in the Summertronics. I will always help you. I think now I'll start this. We type create circuit here, and we do the same thing as we did in the first one. Click here, click here. I'm basically making an RC first order circuit currently, and we'll go to second order also in this. You after okay, this is AC voltage you have to get. Click here to get a wire, and keep clicking and joining all of them. And we add a ground at last. I'll move this a bit farther. I think you could do this by yourself now as you have seen the first one. You can ask me in Q&A. I'll wait here for a while. You can ask me in Q&A if you have any step you wanted to repeat myself. React if you have done this till now. Raise your hand or just say done in Q&A. And also you have to add a voltage analyzing notation here. This point. What's the name of this thing that at the bottom? Ground. I suppose you are talking about this. You have to just get this from here. Am I right? Or I think now I can show you. Just change the interact this part here. Interactive as AC sweep. What this does is it just sweeps the frequencies from 0 to like 1 megahertz or something. Like it tests every frequencies and takes the reading for them. And you once start the simulation, you'll get the graph you are already familiar with, the actual part and the frequency part. If you check this, you'll see at around 45. I can't exactly point at 45. Somewhere around here is where this cutoff actually starts. This is the 3 decibel point, minus 3 decibel point. Now, we also make a second order filter, same as the first one. Add 2 more of this and join the wire. Okay, start from here, not to. You can see this clearly. I hope I will just zoom in. Now we will add also one more voltage probe at this point. This is the output for the second order one. This is the output for the first order one. You can also change the resistance and capacitance values if you want to play with this. But I will prefer to keep it this way. You see, this is a second order filters magnitude line. You can see clearly this is way more steeper than this. And interestingly, the cutoff for this part comes at around 90 degrees. Because phase shift have to be 45 degrees of both the capacitance. Only then you will get the cutoff for the second one. If you have any problems or want me to do something, you can always press it in Q&A. You don't have wire here. You just press the point and move it around. Like I'll show you. Uh, you take one point and move your cursor on it. You will get this reel thing. Left click on it and you will just go wherever between. And where you want to end this point, you again click it there. Attendance. We will give attendance. We will shortly give Google form in the group and here as well. I have sent the attendance link in the chat of this group. We will close it by 12:20. Fill it by then. I'll stay here till 12:20. If anyone have the I'll send it in Q&A. You can leave after you have done your attendance. Yeah, you're welcome. It's been a late, it's been a great opportunity for learn for ourselves as well.